So let's figure out how to incorporate the added complexity of traffic. We had this simple base model where the total drive time is the total distance of our trip divided by the average driving speed of our trip. But, especially around here, my average drive time to get from Fremont High School back to my house in Milpitas could be anywhere between 20 minutes and 50 minutes, depending on the time of day that I do it. And that's about traffic. So a big learning here was I wasn't necessarily expecting people to write time of day as the factor that's affecting the time to destination. I was expecting people to write traffic, but it's not really obvious if you just say traffic affects drive time. How do you incorporate that idea inside an equation? So that's part of the learning here. It's how do you take your kind of natural human idea about something that's relevant and attach a number to it that would then fit into an equation. So, our model in a certain sense is already general enough to incorporate something for traffic because, traffic just affects our average driving speed. So I might say, I could decide if I'm going to be leaving at 4 p.m., my average drive speed is going to be 35 miles an hour on the freeway, and I could calculate my drive time home. But then if I was going to drive at 5 a.m., my average driving speed on the freeway would be like 75, and then I could, again, calculate my total time. So it's like the user of the model could decide what number to use for the average drive speed, and we'd be just fine. But if we're thinking about making a model that's sort of more friendly and does more automatically, it might be nice to include another variable t, which is like time of day. And we could measure t as like the number of hours since midnight, for example. So 0 would be midnight the previous day. 8 would be like 8 a.m. 9 would be like 9 a.m. 12 would be like noon. So here's a really big idea. Instead of average driving speed, let's do one other idea before the really big idea. So one simple idea is I could have t be a piecewise defined function where I could say, let's have it be d divided by, 35 miles per hour if t is between, 0 and, 6 a.m., or if it's between, so I'm imagining, 35, sorry, 35 should be my slow traffic time. This is commute time. So let's do another one that's like not commute time. So here I've got a speed that's not commute time, and so that would be for any times from midnight up to 6 a.m., or from, 10 a.m. up through, 2 p.m., or anytime after 8, it wouldn't be 2, what would it be, 12, so 14, or anytime that's maybe 20 hours, which would be 8 p.m., anything larger than 8 p.m. So it's these are the non-commute times. And if we're in a non-commute time, we'll use this equation. And if we're in a commute time, and you can sort of figure out what your intervals would be here. If we're in a commute time, we'd use that equation. So that's one idea for how to incorporate this idea that the average driving speed is going to be a function of the time of day. And again, part of what I'm doing here, this is our first time or second time deriving theoretical models. I'm just showing you that you can use these ideas flexibly that we've seen in the past. Students tend to be in a mode am I allowed to do this? Am I allowed to do that? And the answer is yes, you are allowed to do whatever makes sense to do. Don't do stuff that doesn't make sense. But this is a perfectly sensible way to say at certain times we'll go one speed, at other times we'll go another speed. So this was 4A, but let me introduce another really big idea here. Here, what used to be our S, it's not really a function of the time of day. It's still sort of a constant number here. So a really big idea when you're making models is you can start with a simple model where this would be a constant number. But then you might decide that this thing that used to be a constant number should actually be a function of something else. So I'm going to make this be a function of the time of day. What should the function be? It's a little bit hard to imagine an equation, but like we can think about it intuitively in terms of a graph. So if this is supposed to be my speed, let's say my maximum speed is going to be 75, my minimum speed is going to be 35, so traffic is never going to make my average drive time be slower than 35. Let's say this is noon. Let's say this is 6 a.m. Let's say this is midnight. Let's say that's 8 p.m. So we could model it this way. At midnight, I'm going really fast. And then by the time it reaches 6 a.m., maybe I'm going really slow. And then by the time it reaches noon, maybe I'm going really fast again. And then by the time it reaches 8 all right, so let's say 2 p.m., I'm going really slowly again. So I'm sort of trying to put a bunch of points that represent the different speeds at different times. And then if we wanted to, we could try and fit some kind of curve to these points, some kind of continuous function to these points instead of a piecewise defined function. What would this equation look like? I don't care for the moment, but you could imagine coming up with an equation. And if you just plug that in equation in right here, now we've got a better model. And the way that we would evaluate this, or the way that we would use this model is, in order to figure out our total drive time, we'd plug in whatever number was our total drive distance. We'd look at our value for time and we'd say, oh, we're doing our trip at 8 a.m. Well, at 8 a.m., our equation says that our average driving speed is going to be 45 miles an hour. And so then you plug in 45 miles per hour here and you're done. So these are the kinds of things that you can do to take a simple model and to incrementally add in complexity that might make it more realistic to the situation.